Okay, so high level though, with Coreum, and I have to say this, the language on this site here, take this enterprise grade thing with a grain of salt, right? That the end result of what I'm going to show you, it allows for a lot more reliability. And with organizations, they don't want any risk, right? So the end result is organizations, big and small, find this useful, right? But I think for a long time the company was focused on enterprise grade, but I think that we're making a slight switch. Not that we're forgetting enterprise people, but we meet way more people who aren't enterprise, right? And that they're really interested. So high level though, and I want to show that, and I want to take it down because there's, I want to start from scratch. So high level though, with Coreum, what we've done, obviously we built it on Cosmos, but what we've done is we've taken fungible tokens and non-fungible tokens, and we made them first-class citizens in the protocol. So obviously you can make both asset types in Cosmos, but we made it where now the asset types are built into the protocol. So when you make them, it inherits all of this foundational logic, so you don't have to implement it yourself. Okay, that's a very high-level way of saying it. It'll make more sense as we go through it. But and I can talk about the modules that we made on top of it, and I'll kind of show you that as we go. But I want to keep it very hands-on, and what I'm going to do is I'm going to take this code and I'm going to put it in a repo on our organization in GitHub, so that you can just go play with it, right? But we do have a tutorial that kind of shows you how to do this. It's just you got to do it yourself, right? And what I did here is I pretty much, this make file here is pretty much automating everything for you, because we have like a daemon that you run that simulates a local node on your computer, so that you can interact with it, right? So, but anyway, okay. So like I said, we have these first-class citizens, or fungible tokens and non-fungible tokens. So, what I'm going to show you is how do you programmatically make a fungible token in this case, but the approach is the same as that thing for non-fungible. And then another thing I will say is, following these steps, you should be able to recreate this on your machine, and if not, just reach out to us and we'll help you with that, right? Okay. So I have never written Cosmos on Spark, to be honest. Good, I'm so glad everybody asked. So now I don't have to, you're going to see how similar it is by building smart tokens. It's the same exact approach as building any type of Cosmos contract. It's just now you have some guarantees up above. Okay. And you guys can see this code, right? It's not too small. Okay. So first thing, and I hate the fact that I have a mic, right? So, and I know it's for them, but you guys hear me? So what I'm gonna do here is I'm gonna just start this is our it's a daemon. It's pretty much running in a container, but this is a node that's running on your local machine. So now you can, everything you're doing here, you should be able to do on any mainnet. So what I'm going to do is I'm going to start it up. Okay, boom. Now it's running. Okay. So now the way that I'm going to interface with it is I'm going to call Core-D. This is just an instance, so I'm going to append it with 00. Check the stats. Okay. So we know it's running now. Perfect. So what I'm going to do is I'm going to do Core-D. First thing what I want to do is let's look at the accounts that are available in the section. So we'll do Core-D, keys, list. So here we see 3 addresses, right? We see Alice, Bob, Charlie. So first thing we're going to do is we're going to make a new wallet for ourselves, so we can actually do some work. We're going to do Core-D, keys, add, and we're going to just call it dev wallet for now. Okay, dev wallet. There we go. So now we have our dev wallet up. If we run this keys list again, now we see we have our dev wallet. Okay, our dev wallet is broke right now. Let's give it some quick fun so that we can actually deploy a contract. And I'll walk you through what the contract is doing line by line, so no worries. And I might not have to do it line by line because all of you have done Cosmos stuff, so I can actually be faster than that. So let's give our wallet some tokens, some native tokens. Core-D 00. We're gonna call the transaction module. Actually, no, yeah, transaction bank module. You send from Alice, and we're going to give it to our dev wallet, and then we're gonna just set ourselves like million native tokens. 10 million. So similar on any Cosm Wasm chain, you're just denote your denomination, your suffix. So then the last thing we're gonna do, broadcast mode. This is just defining if it's async quality.
Broadcast, yeah.
Yes. Okay. So now let's do keys list again, and we're gonna do. Let's just make sure our thing has some funds now. Query, bank, balances. So boom. So now we have some tokens. Perfect. So let's close this real quick and let's look at the actual contract. Okay. So all of these make sense to everybody. These are pretty standard stuff, right? The only thing here we're bringing in a specific struct that we made, and that struct is in our message here. This is a very basic struct. This is just going to hold amount that we're going to return later. So just keep that in mind. Now these are specific to Coreum. So here we're bringing in this one asset FT, and this is, you can do the same thing for NFT. And here we're just bringing in some some structs, right? Just Coreum message and queries so that we can define how we're talking to the actual chain and how we're getting data from the chain. These are all standard, right? I'm sure you guys have seen these before. Yeah. Okay. Good. There's the last thing that we're importing here. This is just custom state. And you guys know in Cosm Wasm, you're defining your state to be, what is your app care about? What is your contract care about? So here we care about, let's store owner, let's store denomination, let's store airdrop amount, and let's store minted for airdrop. Actually, make this a context. So what this is going to do is we're going to mint tokens and we're going to airdrop tokens. Very simple. But because you guys are all Cosm Wasm nerds, you can extend this to whatever you did. Okay. Let's go back. All right, perfect. So this is newer Cosm Wasm stuff, Cosmos SDK stuff, and Cosm Wasm stuff with like the contract version and the contract name that wasn't always there, but it's required now. Everybody here familiar with Rust for sure, so I don't have to explain what these compiler directors do. All they do for people in the internet world, all these are doing here is they just pretty much force these tricks to be implemented on these following structs. This right here is when we actually generate these JSON files, this snake case is going to convert this to all lowercase with underscores between it. So here's our instantiate message. This is custom, right? So you set this yourself. So here, to instantiate a contract using this, we're going to pass a symbol, a subunit, precision, the initial amount, and the airdrop amount. And we'll make sense of that in a minute. Here we're just defining our errors, right? It's a custom error, that's Cosm Wasm stuff. We kind of go over that again. Let's see, here's our execute message. So this right here is important, obviously you guys know. Here we're just allowing ourselves to invoke mint for airdrop, which is actually going to mint more tokens to later be airdrop. And then this received airdrop just disperses them. And just for this toy example, the received airdrop is going to disperse them to the sender, dev wallet. So here, this is just in our execute function. Here we have this match statement. If it's a mint for airdrop, we're going to call this function. If it's a receive for airdrop, we're going to call this function. Super basic stuff. For Cosm Wasm nerds, because if you didn't know, then I have to spend time. What is a match? So all that stuff. Yeah. So here's our query, right? If we query for a token, we're going to call this. We query for a mint for airdrop, we're going to call this. Okay. So here's our first important thing. Here's our instantiate function. Let's take a look at it. So you guys know when you store your Wasm contract on chain, it's just stored there, right? But it's only live when you instantiate it. And every time you instantiate it, you get a new contract. It's very basic stuff. So these are basic, right? These are just mutable dependencies, access to the environment, access to the info on the chain, and then this is the instantiate message that we send. And this obviously maps to the message that we define up here, which is this custom struct. Okay. So here we're setting contract version, basic stuff. This is the first place where we're actually making a smart token. And you're going to see, and just take a look at this. You guys are all developers, right? So here we're just invoking the asset FT, and here we're using this issue struct, and we're setting these parameters, right? So we're setting the symbol that's coming from our one of our parameters. Same thing with subunit, precision, and initial amount. This is blank, so don't kind of worry about that for right now. This is the first thing that you guys may care about. So we talk about these built-in features for smart assets. Here, you're passing in a list, an array of numbers. And this right here is, you see this little comment here is saying 0 is representing minting. So on this, I'm telling it enable mintability. This, I think we have 6 different features so far, and we're adding more over time on our roadmap, but every single feature that I enable in this features field, that's going to enable all of the default logic that I've been talking about all day. This is, obviously we're setting up burn rate to 0, we all know what burn is, right? Destroying tokens. But the key thing to keep in mind here is, this is built-in functionality, right? So if I'm burning and I send tokens, if I send smart tokens, this is burning from my address, right? Keep that in mind. Now this commission, we're actually using this, and there's a last test that I'll show you how this works. The commission is, if I'm sending 1 token, it's going to add a fee in my smart token on top of that, and then that fee is going to go to the issuer of the actual asset, which in this case is going to be our contract. Okay, and this is our denomination. It's just a concatenation of subunit and contract address. That ensures that it is unique. Very important. And here's our initial state. And the rest of this stuff is really just causal modeling stuff. Right? So I'm not going to go too deep into it, but we're setting our initial state, our owner, our denomination. This is a struct, right? So our denomination, minted for airdrop, and our airdrop amount. These are just initial values. Here we save it, and then here we're just constructing the response. Super easy. So, let's see. Okay, so here, this is another function that we're going to call, and we talked about how that match statement is going to map to this. So here, what we're going to do is we're going to load the state, and in Solidity world, this would be analogous to our require statement, right? We only want the owner to be able to mint more tokens for the airdrop, obviously. But this could be whatever we want. Here, we're invoking this asset FT again, and we're using this abstraction, this coin, and so we're actually minting more coins here. And this is just built in, and this will fail if you don't enable mintability, right? But if you enable mintability, then you can actually do it. So here, we're just adding to this value. This, in Cosmosm land, right, if this failed, everything, in blockchain, if this failed, everything will fail. So you don't have to worry about as much the order here, but given certain situations, you do have to worry about that order rigor, like that whole paradigm of like make changes, didn't commit them, et cetera, et cetera. So here we're just constructing our response, saving state here. Yeah, sure.
So yeah, without add message on boundaries. So it's not sending it, it's sending to the protocol, like the message.
Yeah, so this mint is just creating new tokens. The receive airdrop is when we actually do the send. You see what I'm saying? So yeah, you see that this is literally just minting in here, and and what you could do here, instead of hard coding adding this, you could do it another way. But all this is showing is that we're minting, and then we're keeping a static representation of how many tokens we have minted. Because later on, we're going to query this to see how many tokens there have been minted already. Right? So super basic, right? But you could do this a number of other ways, just as a toy example, right? Make sense? Okay. But then after that, we're just saving it, and then construct the response. Super easy. Okay, we're almost done here with the contract. Here we're going to do our receive airdrop. All this is going to do, load the state. We have the simple condition here to make sure that the amount minted is less than the airdrop amount, just so you don't airdrop more tokens than you have. Now we're actually doing the send, which is what you were asking about, right? So, but you see, this is just a Cosmosm bank send. You see? So sending it to the sender, and then the amount, we're just using this coin struct. Here's the amount, here's the denomination, should be easy. But then here, we're just subtracting it, right? Subtracting it from our minted for airdrop amount, saving the state, constructing the response. No questions, right? Super. Any questions? Yeah.
So it's banks and
Yeah, for the smart token. So not the native token, but for the smart token. And then, that's actually a good point because the point here is that they're behaving like native tokens in general, right? But it's because you use our abstraction from our SDK, because if you note back up here, we have our own SDK. It's pretty much a wrapper around Cosmos SDK, but that shows this, that provides the support for the smart tokens. See? And keep interrupting with questions, don't worry. So yeah, so we're treating it like a native token. See, okay. So here's our queries, right? This is just getting, we're loading the state here, right? Then here we're just, creating this abstract, this struct as abstraction with this denomination. And here, this is the result that we're querying. And then we're just returning it. This is actually really, really simple. So almost done here. I'm not going to go over the tests because those are just for sanity check. This is the last function here. Minted for airdrop. This is another query. It's just going to, remember that struct that we made earlier, the amount response at the top? This is just going to return that. It should be easy, but it's going to reference the state only. Simple. Okay. So now let's actually see things in action. So the first thing that we're going to do, so we have money now. And when you get this code, you'll see some of these commands are a little bit lengthy, and so that's why the makefile is there. But so first, let's deploy the code. So let's do make deploy. Oops. No, shoot. Oh, I have to switch. Let's see. Share. Documents, projects. So now we just deployed this onto chain. So if we look at the deploy stage here, so I'm going to minimize the code a little bit so we can look at what I'm doing on the command. So here I'm invoking the core D of my local node, the transaction module, WASM, store. Here's the artifact. I should say this. Here's the build stage that we have. I didn't run it because it would take like 15 minutes to run. So, but if we look at the folder directory, this is that WASM file that's produced after I do my super basic Cosmos WASM stuff. Okay, so I'm storing that on chain from my dev wallet. Automated gas calculation, my gas adjustment, all yeses, what type of broadcast mode, output is JSON, my Coreum node arguments, I can actually show you what that is here. Right here, so I'm just saying, here's my node endpoint, here's my chain ID, super easy. Make sense? Okay. So, if we look at the bottom here, we see that this is successful because we have a code ID. And this code ID in Cosmos land is always unique. Should be. All right. So our next stage, now after we deploy it, what's the next stage we have to do? What kind of Cosmos there? Instantiate. Okay. Well, first let's check, right? I mean, and obviously this is a sanity check right here, but there's a check stage in here. We're gonna have to use this one. Okay. So now let's do our instantiation. I mean, honestly, you guys already know how to do that. We don't have to walk through it, but for people in TV land, let's do it. Let's see that. Oh, let me give myself more funds. So, there we go. Okay. There we go. Here we go. So now we instantiate. So now we actually have the contract locked. So what we can do is I can make, it's actually in these logs, I'm just going to get it the normal way. Just say make contract address. Well, so now here's my contract address. This is going to be super important. So what I've done in the make file, and it's actually not the most ideal way, but I'm kind of working this in a little bit of short time. So I just pretty much have this variable up here where I put the new contract address to make it a little simpler. So, all right. So now we have our contract up there, and we have our contract address. So let's actually check total supply. Let's say make token total supply. This is going to show us how much of the total supply of our smart tokens do we actually have. And this is what we set in our configuration. Okay, So here we also query token metadata. Right, so let's just do make token metadata. So we have our awesome Muslim coin, our awesome coin. I'm a big fan of Final Fantasy, so I use Gil all the time just for nerdy reasons. But this denomination should always be unique, right? Contract address as a suffix, and it's at least this part is arbitrary. Okay. All right. So now we know that our contract is live. We already checked total supply. We checked metadata. So this is the last thing for checks. Let's do. Oops. Let's do make asset FT. So this is just our send commission rate. I'll show you how that works later. Zero burn rate, description, right? But this is important too. So this is going to list to you your features that you enable, right? So it's going to inherit all of this logic out the gate. Another feature we have is like, can you freeze like addresses and stuff like that? Just a bunch of interesting stuff that you would have to implement yourself anyways. Box for you, and audit it, etc. Okay. So let's mint more tokens. So I'm actually going to run this again, this make total token supply. We're going to see what's number. So let's mint more tokens. So let's invoke this. Oops. Airdrop. Cool. So now we minted this many. So now let's actually check to see that number should be bigger. And it is. So now we're actually minting more tokens. Okay? And let's actually do it a few times. Okay. So now we see this one. Okay. So now let's do one thing. Let's look at the balance. Well, at this point, nobody has any smart tokens but this contract. Okay. So if we check the balances for Alice, Jovonni, and Charlie on our dev wallet, it will all say 0 coins. But let's say if we do 4D, let's get our contract address. So now let's actually check the smart token or the balance in general of this contract. And we should see our smart token as a free balance. E00 query, big module balance sheet. Say it again. So see, our contract has these tokens, and it's treated as a balance, as a fungible token balance, which is the point this week. So now let's do receive airdrop. And I don't have to, like when I did mint for airdrop, I don't have to show you guys what the structure is. It's just that basic structure we made super light. I love the fact that you guys are ready. It makes it so easy. Okay. Just to receive airdrop. Boom, it ran. Let's look at the balance sheet contract again. Now it's changed because I sent tokens to the sender of that last transaction. So now let's look at how much. Let's look at the balance of my dev wallet. Right? So 4D, query, let's do keys. Dev wallet address, 4D, query, make balances. Alright, so now you see, now we have our Final Fantasy and Austin coin we did, right? Which is cool. But it's treated as a fungible token. And the same approach you would do for NFTs. It will be treated as a raw NFT and cosmic. Okay. So, let's see. So now I showed you minting for the airdrop, function called and receive airdrop. And here, this is just another query we're just doing. Here we're just like checking, it's a query to check the airdrop amount, which is, at the end of the day, that's going to use this struct right here that we already defined. Right? But it's going to return that to me like this. Right? So it's the same exact struct. Okay, so this last part to show you, let's check the permission test itself. So remember, with permissions on send, well, let's just look at the stage here. So with permissions, all we're doing is calling the make module and send from our dev wallet to Alice. And that's key. So first, before we do that, let's do list again, and let's look at Alice's address. So we're going to port B00, and actually we're literally home. Port B0, and it's already been a half hour. So let's do port B00, we're going to query, make module, balances, and go with Alice. Alice has no Final Fantasy awesome points. So now what we're going to do is we're going to send money from the dev wallet to Airdrop to Alice, and we're also going to see that the contract gets the commission. Okay. Yeah. And so also we'll do let's see, contract address. Okay. So now let's just make sure that we verify what this is on. We'll check the balance of the contract. Just keep that in mind to see the difference. So okay, so this is 199 and 5 zeros. So now we're going to do this stage, this commission test. So we're going to do make commission test. Okay, so now let's look at the balance of dev work. They got the commission, even though we sent it from the dev wallet to Alice. That built-in commission has now been sent to the contract, and that's just by us enabling that. You see, so. But traditionally, you would have to implement that logic yourself. And over time, we're making more asset types, but because, if you saw the talk earlier, we talked about the proliferation of ERC7 21s and 20s, that's majority what everybody uses anyway. So just implementing those and providing those to users, we've seen people be able to make these type of applications like this out the box without having to write their own commission logic, burnability logic, et cetera, et cetera. So, but this last part, at the end of the day, just to recap, we sent tokens from dev wallet to Alice, and then our smart contract or our smart token gets the commission. Makes sense, okay? And so, just to leave you with this, half an hour went by really quick, guys, but I appreciate you guys staying, and I also appreciate your knowledge, so I don't have to tell you what a match statement is, right? So I appreciate that. But just to go back to this, let's look at the function real quick. Well, what we made in our instantiation, where's that instantiation? Here we go. All we did was just make sure that we define this to be non-zero and how it works out the box. So when we look at, let's go back to the receive airdrop, right? This, like I said, worked the same way we expected it because we use this bake send. So we'll make this open source for you guys, but really these tests down here for you to verify to yourself that it's working the way that you expect, right? Nothing really crazy here. But, and this is the last thing I'll say, so if you go back to the instantiation here, remember, this to me is the most important line in this whole contract. Because actually this is 92 and 100 because this is where you're defining your out-the-box logic that will just work for you like we did with set commission. So if we would have put 0, 1, 2, we would have enabled burnability, freezability, right? And you can enable whitelisting and blacklisting out the box. You don't have to write that logic yourself. But super basic contract, showing you how to implement smart tokens, just a fungible token type. If you want to, we have a tutorial for the NFT types as well, super basic, and it will show you the same type of thing. But remember, because this is a cosmos contract, I don't have to tell you guys this, but I'll say it for the internet world, this can be whatever the hell you want it to be, right? As long as we give you this out-the-box functionality so that you don't have to worry about, oh my God, is my commission logic right? Is my burnability logic right? This should hopefully, ideally, let you move faster. So hopefully, this is valuable to you. Hopefully, it demystifies the smart token thing to being, hey, there's some given logic that has already been tested and implemented that we're now inherited from. And hopefully you can move faster. If you can't move faster, we're not doing our job right, but hopefully it shows you it's not rocket science. You guys already know cosmos, this should be easy for you to pick up. So the last thing I'll say is, I said this earlier, but we have a very interesting grant program, and me and my business partner there are in charge of the grant program. So if you guys are building anything interesting or you have something built already, if you're open to incorporating Coreum meaningfully, let us help you get to where you're trying to go. If you have ideas on extra features you would like to see, please let us know. We're really responsive to devs and we build stuff pretty quickly. So, yeah. Thank you.